Hello, my name is Aaron and I am a rising junior at Lynbrook High School. And for my main intensive project, I set out to create a classifier that would work in real time to determine if a person is smiling or if they're not. Here's a demonstration of it working. Since the first milestone, the only real visible change is that there's the addition of one or two words floating above the box around the face, smiling or not smiling. But the process in arriving to this point was definitely a lot more complicated than that. Since the first milestone, I've taken the existing dataset known as the Olivetti face dataset from online, and then using the IPY widgets library combined with Jupyter Notebook, I created this simple user interface that would display a face along with two buttons that I would use to classify the face as smiling or not smiling. Now that I had my training data, I saved it in a .xml file using the JSON library, and then using the sklearn library, I was ready to train my very first classifier. At this point, now that I had my classifier, I wanted to have an estimate of how it might perform on general data. And to do so, I used a method known as k-fold cross-evaluation, in which the training data is split into k number of groups, and k number of classifiers are trained on these groups by taking a different portion of the training data as the training set. And in doing so, I now had k classifiers and k number of their accuracies, and taking the average of these accuracies gives me a general estimate of how a classifier trained on the entire data might perform. Another method I use to obtain an estimate of how the classifier might perform is by splitting the training data into just two groups this time, one training, one classifying, and making just one classifier, but along with it, a confusion matrix that looks like this. Now, although a confusion matrix may appear as just a confusing jumble of numbers and decimals, two values are particularly important, and they are precision and recall. If there is a high recall but a low precision, this means that the classifier uses that label overly liberally, in which all the correct cases might be correctly classified, but there are also many incorrect cases that are given the same label. This means that there would be a lot of false positives. On the other extreme, if there is a high precision and low recall, this means that the classifier uses the label very sparingly, but when it does, it almost always gets it correct. In a small classifier, it is best to have a balance of these values, but at this point I now had my smile classifier, an estimate of how it might do, and my facial detection software from the first milestone. But before I combined the two together, I realized that when extracting the face from a frame in a video stream, the face ends up distorted and stretched. And in order to fix this problem, I took two testing images and had a mapping of the vertical stretch component with respect to the horizontal stretch component in order to obtain these maps. Here is a final combined mapping of the two testing images, in which these two red patches are coefficients of stretching that resulted in misclassification. Finally, I had all the parts and I combined it all to create the finalized product that you saw at the beginning. In reaching this point, I definitely learned a lot about machine learning and the various methodology employed in different tasks. This was a simple single class classification in which I used a linear support vector method in order to solve it. In reaching this point, there are also definitely many struggles, one of which was the constant struggle of having to learn new methods in all these various libraries and what they might be used for. Another struggle that I had was that after building my first finalized version, it ended up performing subpar, and I ended up attributing this error to the initial classification of the Olivetti dataset. And so to solve this problem, I went back, reclassified it twice more, and created a total of 3 finalized products, in which this was the last and best performing version. This experience was definitely very rewarding and opened my eyes into the world of machine learning. For my next step, I hope to take a more sophisticated method such as the CNN method and apply it to a more advanced task such as the multi-class classification of facial expressions. Thank you for your time.